Assalamualaikum warahmatullahi wabarakatuh to all of you. So today we will be going to present about the experimental and theoretical probability, which is picking up a sweet. Before that, we are from RCDCS 143 3D and our lecturer is Madam NOUR Binti Muhammad. Before we start, let me introduce our group members. The first one is me, SOFIA ADDINA binti ZULKIFLI, and Dalila Arysya binti SABRI, FARHAINI binti Muhammad RAZALI, and SIRRAH NASYWAA binti JASARUDIN. Now, let me explain about the introduction. So what is the significance of this project? The significance of this project is to focus on understanding the probability through a sweet picking up experiment and apply it in real life. By conducting an experiment involving sweets pickup, we will evaluate the possibility of each outcome. So through this process, we explore the concept of experimental and theoretical probability. By comparing the experimental result with the theoretical possibilities, we will gain insight into the relationship between all sweets. Now, let's move to objective. So, the objective of this project is to calculate the experimental probability for each flavors. The second is to analyze the differences between the theoretical and experimental probabilities. Then, to calculate the theoretical probability for each flavor. And the last one is to find probability and EX by using the formula that has been studied in class. Next is methodology.
So hi, today I will show you how to do this experiment. So here we have 3 different flavors of sweet. First we have chocolate, coffee and blackcurrant. Chocolate we have 9 and then 14 coffee and 7 blackcurrant. So now we put all the sweet in one container or bowl here. And then after that we're gonna mix them so they are well mixed. So this is the result of mixing the sweets. After this, my friends will show you how to demonstrate the next step.
First, they will close their eyes and mix the sweets while picking up one sweet from the bowl. Next, they show the sweet flavor and then they will record the frequency of the flavor. So lastly, they will repeat the steps for 30 times. This is how you do the experiment.
Next is finding and calculation. First question, we need to observe and record the frequency of each flavor for those sweets from the experiment that we made. This table shows the result of our experiment. For question B, we need to find the experimental probability of the flavor. To get the experimental probability of the flavor, we need to take the frequency of each flavor from the experiment divided by 30, which is the total of all sweets that we have. For question C, we need to find the theoretical probability of the flavor. To get the theoretical probability of the flavor, we need to take the real total of each flavor, which is chocolate is 9, coffee is 14 and blackcurrant is 7. Then we divide that with 30. For question D, E and F, we need to find the difference between experimental probability and theoretical probability of each flavor. To get that, we use the formula of experimental probability minus theoretical probability. The answer that we get, we need to multiply by 100 since they want in percentage.
So now, let's calculate the following questions. The random variable x denotes the number of hours of cloud cover per day at a BBO weather forecasting center. The probability density function of x is given by fx equals to x squared minus 24x plus 144 over t. And x is greater than and equal to 0 and smaller than equal to 24 and 0 otherwise. So, first question is to find the value of t. So here's the calculation. Let me explain about it a bit. So 1 over t, integrate the limit of x is 0 to 24, x squared minus 24x plus 144 dx equals to 1. And then we need to substitute the value of x into the x equals to 1, and then you will get t, which is 1152.
For the second question, we are solving a problem to find the probability that the BBO Weather Forecasting Center has less than 9 hours of covers. To do this, we need to integrate this function over the range from 0 to 9 to find the probabilities in that interval. First, we take the constant factor outside the integral, leaving the quadratic expression to be integrated. The quadratic expression has 3 terms to be integrated. We integrate each of them separately. Next, we evaluate the result of the integration at the upper limit of 9. We substitute 9 into each of the terms and then we simplify by adding this result together. After simplifying at the upper limit, we subtract the value of the expression at the lower limit, which is 0 in this case. Since it's 0, the subtraction doesn't change the result. Finally, we divide the calculated value by the constant factor that we took out at the beginning. This gives us the final probability. After performing all the calculation, we find that the probability of the weather forecasting center having less than 9 hours of cover is approximately 49.22%. In this slide, we are calculating the expected number of hours for cloud cover at the BBO Weather Forecasting Center. The expected value, or mean, is found using the formula where we multiply the variable of x by the probability density function of fx, and then we will integrate over the range of possible values. First, we will factor out the constant term from the function. Then, we will focus on integrating the remaining terms. Once we finish the integration, we evaluate the resulting expression at the upper limit of 24. This involves substituting 24 into each of the terms. After simplifying this calculation, we will subtract the result of substituting the lower limit. But since it's 0, the subtraction won't change the result. The simplified value of the integral gives us the expected value. After dividing by the constant term, we get the final result, which is 12. Which means the expected number of hours of cloud cover at the Weather Forecasting Center is 12 hours. Thank you. In this experiment, the probability of obtaining the same flavor is difficult. As we know, the result that we obtained got 3 different flavors in the first 3 trials. Experimental probabilities are the result that we gain when we pick one of the candy from the bowl, and the theoretical probabilities are the result that we expect we will get. After we calculate experimental probabilities and theoretical probabilities, we need to find the difference between both of them. By doing this experiment, we have a better understanding toward this topic, and we could understand the calculation to solve the related question more clearly. In general, this experiment gives us valuable insight for this topic for both understanding and practical application. By engaging this topic by some simple experiment, students can use this for their aspect in life and decision making. Thank you.
Thank you for watching. Bye.